Okay, so I want to talk about units 6.3 and 6.4. And I would use skip over 6.3, but I just realized this year I found it kind of interesting. So the idea is, how do you prove a quadrilateral is a parallelogram? Well, 6.2, we defined what a parallelogram was. We said that a parallelogram was a quadrilateral whose opposite sides are parallel. And then using our triangle proofs, we were able to show these 5 other characteristics of the parallelogram. You have it in your notes. Once again, we were able to show that a diagonal creates 2 congruent triangles. We were able to show that consecutive angles are supplementary. We were able to show that opposite sides are congruent. We were able to show that opposite angles are congruent. And we were able to show that the diagonals bisect each other. That was 6.2, and you did all those algebra problems. A couple of proofs thrown in. Once again, we know in a geometry class, we also end up going back to the algebra. Now, what is 6.3? 6.3 says, how can we actually, if I give you a quadrilateral, what do I need to prove that we actually have a parallelogram? What information can be given so that I can get to opposite sides are parallel? And what's interesting, this is kind of cool, if I say quadrilateral ABCD, let's see, if I tell you that quadrilateral ABCD has any of these characteristics, that's enough to prove it's a parallelogram. And let's just pick one. Once again, if I say that quadrilateral ABCD, for example, I say that, let's say I tell you that the opposite sides are congruent. Prove it's a parallelogram. So, let's say, oh, wrong eraser, I gotta read this. Oh, no, they're both bad. Sorry, guys, sorry. Okay, so this is kind of cool. So, let's see. In quadrilateral A, B, C, D, let's draw the picture. A, B, C, D. I tell you that AB is 8, and CD is 8, and AD is 15, and BC is 15. The question is that a parallelogram? The question is, just by telling you the opposite sides are congruent, can I get back to opposite sides are parallel? And the answer is yes. Let's do a proof of this. So yeah, let's see. So let's see. So proof ABCD is a parallelogram. So step 1 first says AB is congruent to CD, given. We know that AD is congruent to BC, given, right? What else do we know? We know that, I'm going to draw a diagonal in here. I know that AC is congruent to AC. Why? Reflexive. Let me use a different color because my black pen is going dry. What's next? Well, I have side, side, side. Triangle ABC is congruent to triangle, let's see, up 8 over 15, up 8, no, up, so triangle CDA, Y, side, 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 right? What's next? Well, I'm going to stick some numbers in here. 1, 2, 3, 4. I know that angle 1 is congruent to angle 4, and angle 2 is congruent to angle 3, y, CP, CTC. And what do we have here? And we're done, right? What can we, so we know if this is congruent to that, that means that BC is parallel to AD. Why? Why are they parallel? Well, because the converse of the parallel lines. If the alternate interior angles are congruent, the lines are parallel. Let's just write that. Converse of alternate interior angles. And actually, you know what? Let's use green for 1 and 4. 1, because of CPCTC, is congruent to 4, and therefore, AB is parallel to what? CD, same thing. Therefore, ABCD is a parallelogram. Now, maybe in the exercise, once again, you're not responsible for this whole proof. Maybe in the exercises they might say, given the consecutive angles are supplementary. Well, that's easy because supplementary angles immediately implies that if angle A and angle B are supplementary, that immediately, the converse immediately implies that AD is parallel to BC. They might say, because the opposite angles are congruent. So, you would work something out. But the idea is, if you're given any of these characteristics, once again, if you're told that a quadrilateral has any one of these characteristics, you could technically prove the opposite sides are parallel, and you have a parallelogram. Obviously, we know from experience, the book is going to move toward algebraic solutions. So take a look at the board before I erase it. Okay, I'm erasing. Okay, what I want to do next is, I want to talk about more. First, I want to create what we've been doing. I haven't given you the chart. I don't believe I've done this. So let's talk about quadrilaterals, actually. There's 3 sections of quadrilaterals. The first type is the parallelogram. And then there's other 2 families. There's the trapezoids. And the last one is the kites. Now, the parallelogram has 2 pairs of parallel sides. The trapezoid only 1 pair of parallel sides. And the kite has 0 pairs of parallel sides. That's what we're going to talk about. It's called a kite. Now, in America, we call it the trapezoid, but in England, they call it a trapezium, but it's an American class, so we're calling it a trapezoid. The parallelogram, we had the parallelogram, and then the parallelogram breaks up in 2 parts. There's the rectangle and the rhombus. The rectangle, which we're going to learn today, I'm going to just tell you right now. The rectangle, let's just go through, there's rectangle and rhombus, and then when the rectangle, okay, let's talk about the rectangle and rhombus. What is a rectangle? A rectangle is, it's a parallelogram, so it has all congruent angles. What's the rhombus? It's a parallelogram, so it has all the characters of the parallelogram and all congruent sides. Okay? And then the last thing, what's the last thing? What's the last important shape? It is the square. And so the square is basically what happens when the rectangle and the rhombus get together and make a baby. They make a square. The square, it's a parallelogram. So it has all these characteristics, all congruent angles, and all congruent sides. Just quickly, what's going on over here? The trapezoids. We have 2 important trapezoids. We have the isosceles trapezoid, and we have the right trapezoid. Can you see it over there? The isosceles trapezoid is, actually, let's wait for this next day. And then the kite, we're going to see what looks like 0 pairs, like a diamond almost. So this is not parallel, neither of these sides are parallel. What we're going to discover with the kite is that the diagonals are actually perpendicular to each other. But today I just want to focus, so here's the main chart. And we're going to be covering the kite and the trapezoid the next lesson. But today, I just want to talk about the rectangle, the rhombus, and the square. So copy this chart down. I'm going to erase it. Okay. So quickly, let's just, what do we want to talk about? Okay. What about the rectangle? A rectangle is it's a parallelogram. Parallelogram with congruent angles. It's visually going to look like this. It's not going to look like, we haven't defined square, but we know the sides are clearly not congruent. Maybe they are, maybe they're not. But what's important is that all the angles are congruent. That's what you're going to visually see in a rectangle. And they're all congruent. We know that from the first lesson, 6.1, the sum of the angles of a quadrilateral is 360 degrees. If they're all congruent, each of these is a right angle. Okay. What else do we know? What's the characteristic? The diagonals are congruent. That's rectangles, yeah, they're nice. And a lot of Pythagorean theorem questions can be asked. You know, the diagonal, for example, let's say the side is 8 and 15. You know, what's the length of the diagonal? And you would say, okay, Mr. Adler, well, if this is 8 and this is 15, if this is a right angle, I know from Pythagorean theorem that, let's call this d squared equals 8 squared plus 15 squared. And, you know, you go to your calculator, or you can do it what's 8 times 8? 64. What's 15 times 15? 225. You know this is 289, and so d equals 17. Probably a calculator question. It doesn't hurt to know that 225 is 15 times 15. It doesn't hurt to know that 289 is 17 times 17. Rectangle, yay, love it. But we like it, but I love the rhombus. I love the rhombus. What is the rhombus? It's a parallelogram with congruent sides. And that's kind of cool. The rhombus it kind of looks like this. And you might say, well, that looks like a parallelogram, Mr. Adler. Yeah, that's why you need to be told what these things are. Don't just look at the shape and say, oh, I think it looks like that. You need to be like, no. What is this? Well, I'm telling you it's a rhombus. And the idea is, it looks like that. Here's kind of cool. Here's the great thing. The diagonals are perpendicular. Right? That's kind of cool. I think that's kind of cool. So you always draw it like this. The diagonals in a rhombus are perpendicular. Once again, the rhombus also takes on all the characteristics of the parallelogram. So these diagonals bisect each other. But another great thing about the rhombus that's unique to the rhombus is that the diagonals are angle bisectors. The diagonals are angle bisectors. That's kind of interesting here. Once again, that means this angle is congruent to that angle. Now, because it's a parallelogram, the opposite angles. So this is congruent to that. All four of these angles are congruent. Right? That's kind of cool. It's interesting. So what I want you to do now is I want you to prove that the diagonals of a rhombus are perpendicular. So write this down. I'm going to erase. Sorry, guys. Write this down. I'm going to erase. So once again, let's prove this. So let's erase this. Prove the diagonals of a rhombus are perpendicular. Okay, so we have A, B, C, D. What do you think? So when you think about it, well, let's draw in my diagonals. Let's draw them in, and let's draw them in, right? And let's say they meet at point E, right? And our goal is to prove that angle 1. Our goal is to prove that angle 1 and angle 2 are 90 degrees, and therefore we can show that if they meet at 90 degrees, then those two diagonals are perpendicular. What do you think? So, where should we start? Well, I have a bunch of triangles. Prove triangles congruent. That's your goal. Once again, it always comes back to the triangle. So, let's start. How about let's see. AE is congruent to EC. Why? Well, that thing is a parallelogram. Therefore, the diagonals bisect each other. Definition of parallelogram. Let's see. What else? I know that BE is congruent to BE. Well, that's easy, reflexive. Can I prove anything else congruent? Yeah, because what did I tell you that thing is? It's a rhombus. And what was the definition of a rhombus? All the sides are congruent, which means that AB is congruent to BC. Do I have enough to make a statement? Yeah. Yep. We know that triangle ABE is congruent to triangle CBE. Why? Side. Okay. What's next? Well, I'm getting closer. I want that 1, 2. I want to see if I can prove those are right angles to show that it's perpendicular. I don't have that yet, but I do know that they are congruent. Why are they congruent? Very good. C. Well, but they also have another relationship. What's the next relationship? Angle 1 plus angle 2 equals 180. Right? Linear pair. You know what I can do? Substitution. And then angle 1 equals 90 degrees, which equals angle 2. I'm kind of picking up the last pace here. Therefore, substitution, right? So once again, I know that angle 1 equals angle 2. I know that 1 plus 2 is 180. Therefore, 1 plus 1 is 180. Therefore, angle 1 is 90. But because they're both congruent, they're both 90. Therefore, I'm done. AC is perpendicular to BD. Definition of perpendicular. If two lines meet at 90 degrees, they're perpendicular. So we just proved that the diagonals of a rhombus are perpendicular. Once again, we're just going to slow very slow reasoning of why this is true. That's the idea. We're taking it once again. This is math. We're making it very clear through our argument why this is true. And you might say, well, we could have done it faster. We could have, yeah. But we're just making the slow steps through the whole thing. You can prove that the diagonals are angle bisectors on your own. Yeah. I mean, you could technically say all four of these triangles are congruent. Therefore, this angle is congruent to this, and this is congruent to that. That's one. But that's the idea. Now you can use that. So I have a question now. Are you ready for the question? Listen up. I'll repeat it 2 times, and then I'll write it on the board. And you're going to use the Pythagoras theorem. The diagonals of a rhombus are 10 centimeters and 24 centimeters. Find the perimeter and the area of the rhombus. Once again, the diagonals of a rhombus, sorry, I'll sound this out if you need to copy this. The diagonals of a rhombus are 10 centimeters and 24 centimeters. Find the perimeter and the area of the rhombus. The diagonals of the rhombus, can you see over there? Yeah. Are 10 centimeters and 24 centimeters. Find the area and perimeter. In either order. When you figure out all the sides and figure out what you can figure out first. Some of you might say, well, I can find the perimeter first, then the area. Go for that. Some of you might say, I can find the area first, then the perimeter. Go for it. Whatever you want. Okay. Well, what do you think? Well, I have a rhombus, and I know, whoops, let me make a better diagram. Here's my rhombus. The diagonals are perpendicular. So one of the diagonals is 10, one of the diagonals is 24. I know they're perpendicular. I also know, because it's a parallelogram, that the diagonals bisect each other. So I have a 5, and this is a 12. Well, I know from Pythagoras' theorem that this side is 13. So I know that the perimeter is equal to 4 times 13 centimeters, because all the sides are congruent. So I know the perimeter is 52 centimeters. The question is, what's the area? Easy, because this is great. The area is base times height. 1/2 the base times the height. But there's four triangles in it. Once again, everything comes down to triangles. Turn everything into triangles. It makes your life much easier. And so we see here, it times 4. Let's see, 60 times 2, 120 centimeters squared. The last thing I want to talk about is the square. And this is just very basic. We're done, basically. What did I say a square was? A square is a parallelogram. It's a rhombus. And it's a rectangle. And that's basically it. So once again, the definition of a square is not all the sides are congruent. No. That's rhombus. The definition of a square is not all the angles are congruent. That's a rectangle. The definition of a square is all the sides are congruent, and it's a parallelogram with all congruent sides and all congruent angles. The homework is just a lot of algebra, probably, and some proofs. Once we finish the trapezoids and the chias, we're gonna talk about another method of proving, and that's basically it. So for homework, you're going to be doing the exercises in 6.3 and 6.4. Probably just do the odds.